Okay, this is the homework help video for Honors Math 3, Unit 3, Assignment 7 for the complex conjugate root theorem. Okay, and I'm going to work out question numbers 1 and number 4. Okay, so for this one right here, the directions are asking us to find all of the roots given the function below and given one of the roots. So the first thing we want to do is we want to take a look at, okay, what are our roots? So the root that was given to us is 5i. So we have 5i is a root. And then because if we have a complex root, it has to come in a conjugate pair. So that means if there is a positive 5i as a root, that means there has to be a negative 5i as a root. So anytime we have one imaginary root given, we're actually given two of them because we have its conjugate pair as well. So once we get the root, we want to create its factor. So to create its factor, we know that if x, or if 5i is a root, then x minus 5i is its factor. And why is that? That would be its factor because if x were equal to 5i, then I would get 0. So 5i minus 5i is 0. So if 5i is the root, x minus 5i is the factor. And then the same here. So this would be x minus negative 5i, which would just be a plus, yeah? And so that would be because if x were negative 5i plus 5i would be 0. So there are my roots, and there is my factor. So once I get that, I want to distribute that to create a trinomial with integer coefficients instead of imaginary. Okay, so I want to distribute my conjugate pairs. So when I distribute my conjugate pairs, my purpose of doing that is to create some sort of polynomial that does not have the imaginary numbers, right? So we would have integer coefficients. So because these are conjugates, when I distribute them, I'm going to multiply x with x, which would give me x squared. And then if I were to multiply x with 5i and then x with negative 5i, those two would cancel each other out, right? That's the beauty of the conjugates, is your middle terms will always cancel. So I don't need to write that down because I know they're going to turn to 0. And then now I just need to multiply my last terms together. So negative 5 times positive 5 is negative 25. And then I times itself would be I squared. And so one of the things that we need to remember is I squared is equal to negative 1. So I squared equals negative 1. So then when I think of that, that's being multiplied, right? So that means I would have x squared minus 25 times negative 1 instead of I squared. And then that double negative gives me the positive. So all I did right here was I knew that 5i and negative 5i were my roots, and I created the factors and distributed, and then that gave me something to work with that although the roots are imaginary, the factor now has no imaginary numbers in it. And why do I want to do that? Because I want to be able to divide. So now that I have that, so let me scoot this down just a little bit. Here we go. So I'm going to take this right here. So this is a root, right? Or a factor, excuse me. This is a factor of my cubic that I started with. So now I'm going to do long division. So I have x squared plus 25. That was what I got right here. And then I want to divide that, so that's my divisor, into the cubic polynomial I was given at the beginning. So now I should get a remainder of 0 because I'm saying this is a factor of it. So if it's a factor, I need to get a remainder of 0. So if I don't, I know something went wrong. So now for long division, I want to know what does, or x squared multiplied by what will give me 2x cubed. So what do I need to multiply x squared by to get 2x cubed? And so if I multiply by 2x, then I will get 2x cubed. And then distribute this to both. So that gives me 2x to the third. And then plus 50x. So now I don't want to put it underneath here, which I started to do. I want to move it over here, don't I? So that my like terms are aligned. So 2x cubed, but this is 50x, so I want to put it under the x term, not the x squared term. And then I want to go ahead and subtract. So that will be 0. And then 3x squared has nothing to subtract from, so I'll just bring that down. That will be 0 as well. And then the plus 75 will come down, but I'm going to write it over here so it's closer to itself. Or they're closer to each other, I mean. Okay. And then now I start over. So what do I need to multiply x squared by to get 3x squared? And that would be by 3. And then once I get that, I want to distribute it to both terms of the divisor. So 3 multiplied by x squared, and then 3 multiplied to 25. And then when I subtract both terms, and then that gives me a remainder of 0. And again, if I got, like, say, a remainder of 5, I should go back and look to see where did I go wrong. Okay? All right, so what do I have? So my function now should be when I multiply these two things together, I should get that there. So when I multiply my divisor by my new factor, so 2x plus 3, that product will give me this right here. Yeah? And so that's one thing I could do to check it, right? If I was like, oh, did I do this right? I would distribute this out and see if I got that cubic. So now that I have it factored, I just want to find my roots. So the roots I gave you initially, right? So I gave you the positive 5i, but then it's a conjugate pair, so there's also negative 5i. So that came from this, yeah? And then the root for this is when I equal that to 0, and so that would be negative 3/2. And so just to make sure how I did that, so I'm just going to do that right below here. So if I do this equal to 0 and solve that equation, I would subtract 3. And then divide by 2. And so that's how I got that other root. Okay? So there's my factored form over the integers and my roots. Okay. All right, let's take a look at one more here. So we'll do number 4 also. Okay, so for question number 4, so this was one of the roots I was given. And so then it comes in pairs, right? Our complex roots always come in conjugate pairs. So my two terms are -1 and 3i. So, but instead of subtracting, my pair would be the positive, right? So these are conjugate pairs. So subtraction versus addition, and then -1 is the same, 3i is the same. So now I want to convert these into factors. So my factor would be x minus that whole thing, right? And I want to make sure I have that grouped because I want to recognize that I'm subtracting both terms here, right? So I want to make sure I keep that grouped. So then my other factor is going to be x minus this root here. And again, keep that grouped so I recognize I'm subtracting both terms. Okay. And then we're going to go ahead and distribute that. I'm going to actually do that on this side over here. So when I distribute, I'm going to have that negative is going to distribute to get rid of that extra set of parentheses. So I will have x and then distribute the negative, so a double negative would be a positive, so +1. And then distribute the negative here, so double negative is a positive, so plus 3i. So that would be x plus 1 plus 3i. And then for my other factor, so distribute your subtraction in here. So double negative, so that would be a positive. And then a negative times a positive is a negative. All right. So when I get that, I want to make sure I'm paying attention to the fact that I want to create conjugates, because whenever I multiply conjugates, it comes out a lot cleaner. So I want to regroup this, and I want my x plus 1 to be a term. And so the reason I'm doing that is because now when I look at this, I have conjugates created. So x plus 1 now is my first term. And then I have the positive and the negative 3i. So then that's creating a conjugate pair, right? So this is one of them, and this is the other, and then adding versus subtracting. So then when I distribute, I would multiply x plus 1 by itself, so that gives me x plus 1 squared. And then 3i times negative 3i, so negative 9i squared. And then I don't have to do the middle terms just like the last one because those middle terms will always cancel. Again, that's the beauty of conjugates. Okay? All right, so I want to simplify this a little bit, so I'm going to go ahead and distribute this out. So squared meaning there's two of them. And then I squared is the same as negative 1. So distribute. So I would have x squared, and then this time I have to actually multiply those middle terms because they will not cancel because they're both positive there. So all I did was FOIL that out or distribute that out. So x multiplied to x and also to 1, and then multiply the 1 to x and then also to a 1. And then a negative 9 times negative 1 is a positive 9. I can combine those terms and those terms to give me x squared plus 2x plus 10. So what did I do here again? So I turned my factors here that have imaginary numbers in them, or complex numbers, and I multiplied them together to create, in this case, a trinomial with all integer coefficients. So I took the imaginary factors and multiplied them to create a trinomial with integer coefficients. So now I want to divide. So I'm going to take this and create that, or have that be my divisor. And then I'm going to divide that into my original problem here. And again, as long as I'm doing everything correct, I should get a remainder of 0 because I'm saying this is a factor, right? It's actually two factors together. So if it's a factor, I should get a remainder of 0. And then my goal is to create another factor up here to be able to have it completely factored. So what do I multiply x squared by to get x to the 4th? It was x squared. And then now distribute that to each of those terms. So that would give me x to the 4th, and then plus 2x cubed, and then 10 times x squared is 10x squared. And then now I'm going to go ahead and subtract those, and when I do, I'm subtracting all of them. So subtracting across the board. So that would give me 0, and then 3x cubed minus 2x cubed is 1x cubed, and then that would give me 0 as well. And then I'm going to carry both of those terms down. And then when I do that, I'm going to figure out what do I multiply x squared by to get x cubed, and that would be by x. And so then that would give me x to the 3rd. Oops. I think I messed up somewhere. Hold on, people. I have a mistake, but I have it worked out ahead of time. So let me look to see where I messed up, because the reason I know I messed up is I'm not going to get a remainder of 0. So let's see what I did wrong here. Give me just a second to peruse this. Oh no, I guess I did that right. Okay. No, I'm good. Okay, so this gives me, but I am going to put in my 0x squared. Sorry. All right. So let me try that again. Okay, so let me, so 10x squared minus itself will give me 0x squared. I'm going to go ahead and put that in there. And then carry down my 6x and my negative 20. There we go. That's what I was doing wrong. Okay, so all I did was insert that 0 in so that I can track it. All right, so now I'm going to go ahead and multiply everything through by x. So I would get x to the 3rd, and then 2x squared, and then 10x. Now we're going. Okay. So now again, I want to subtract all the way through. So subtract, subtract, subtract. So 0 minus 2 would be negative 2, and then 6x minus 10x, and then carry down that negative 20. And one more time here. So what am I going to multiply x squared by to get negative 2x squared? And that would be negative 2. And then I want to distribute that negative 2 to each of those trinomial terms. So negative 2 to the first term would be negative 2x squared. Negative 2 to the middle term, so that would be negative 4x. And negative 2 to the 10, so negative 20. And then subtract each, which will make those all positive, giving me my remainder of 0. There we go. All right, so 10x squared minus 2x squared, so 10x squared minus 2x squared, and then 2x squared minus 10x squared. So 10x squared minus 2x squared, and then 2x squared minus 10x squared. So 10x squared minus 2x squared, and then 2x squared minus 10x squared. So 10x squared minus 2x squared, and then 2x squared minus 10x squared. So 10x squared minus 2x squared, and then 2x squared minus 10x squared. So 10x squared minus 2x squared, and then 2x squared minus 10x squared. So 10x squared minus 2x squared, and then 2x squared minus 10x squared. So 10x squared minus 2x squared, and then 2x squared minus 10x squared. So 10x squared minus 2x squared, and then 2x squared minus 10x squared. So 10x squared minus 2 My function now is my divisor here, and then multiplied to this one, right? So these two multiplied together should, if I were to check it, should distribute and give me that quartic that I started with, okay? All right, so I know this one came from my imaginary factors, so I want to try to factor this one more time. And so I would get x and x for that x squared, and then factors of 2 are 1 times 2, but one of them needs to be negative, and so I want my 2 to be positive and my 1 to be negative. So that would give me x squared, right? And then 2x minus 1x, which is 1x, and then 2 times negative 1 is negative 2. And so then my roots are the ones that were given, so that was for this pair right here. So way back here at the beginning, right, those are my original roots that were given, so I'm going to write those down. So that was negative 1 plus n minus 3i. And then my roots for here, so what would x need to be to have that be 0? That would be negative 2. And what would x need to be to have that be 0? And that would be 1. And that's it.